Hello and welcome to PWA Summit 22, everyone. My name is Kenneth Christiansen, and as you probably guessed from looking at my background on my slide, I work at a company called Intel. So I'm here today to tell you about why we at Intel believe that creating modern progressive web apps is a winning combination for creating great desktop experiences. We often call this for clients at Intel. So first of all, let's look at the vision at Intel. The vision at Intel is that we see the web as an unquestionable key application platform. So we really want to work on this is the vision we see for the web, where we want it to go. So we want to make sure that it offers the best building blocks for creating applications, and that the application will have like very close to native-like performance, and also offer all the capabilities that you need for creating these applications. So, for instance, if you have an application that you want to measure your heart rate and that requires Bluetooth, obviously you would need the capability to connect to Bluetooth devices on the web. We also know that the web offers a set of unique strengths that sets it apart from, for instance, other native apps like Android apps or Windows apps. For instance, everything is just a click away or link away. You can share these links with your friends, family, and instantly you're into the experience. The web is also designed to be safe because you visit a lot of different websites every day. So it's very important that you don't get hacked and you don't lose your other data, like access to your files in your system and all of that. So we want to strengthen these core benefits of the web as we're trying to make it more of an application platform. So we think that the web is really on the right path. It's really becoming a great platform for creating apps, and we see that with all the examples of applications coming to the web. We have a solid building blocks for creating progressive web apps, such as the web app manifest that Laura just mentioned, and service workers, but also for doing like great layout. We have new features as CSS grid, container queries, and the like. And we see a lot of design systems today being built with web components, and things are really getting better and better. One of the things that has annoyed me a bit is like when I was creating like single page applications. I really needed, like, you have to deal with URLs, the session history, and it was really difficult to make this nice transition from one clicking on, for instance, on the video and having go full screen and all of that. But all of this is being solved as well. We're having new APIs as URL pattern. I actually wrote a polyfill for that. There's the navigation API, a new replacement for session history, and there's even like the shared element transition spec coming soon that allows you to create all these nice animations. So I think we're doing really, really well. We also have a relentless focus on performance. So we're having WebAssembly today that allows you to take your existing code, for instance, Rust, C++, C code, bring it to the web. Or if you see that there's a bottleneck in your application, you could rewrite that in native code and have it perform very close to native performance. Intel is also working a lot on the media pipeline. So basically, when you're doing something like a video chat or like a conference show, like right now, we're working on accessing all the native hardware in your system. For instance, you might have like native support for background blurring that's super efficient, or like auto framing, making sure that you're always in frame, or maybe even eye gaze correction. And even something as important and interesting as machine learning, we're bringing to the web. So a lot of this is part of what we call Project Fugu that Laura also mentioned. So one of the things you might be wondering, well, Intel is a semiconductor. You do chips and graphic cards and all of those things. Why do you care about the web? Well, it's kind of pretty basic. Like if we're mostly in desktop systems like Windows and Chrome OS, and we really want applications, because why would people use desktop systems if they don't have applications? So today, a lot of companies, like, you have to support a lot of different platforms. Mobile is very important. So maybe you need to support Android, iOS, Windows, Mac, Linux, Chrome OS, many different platforms. If you have to build a native application for all of these platforms, you probably don't have the skills, you can't find the skills, you probably don't have the money either. So you need something cross-platform. And what we have seen is that the web is really taking off. Like a lot of those applications are becoming progressive web apps. and some that maybe don't have the features on the web yet. Those are like hybrid apps, maybe using something like Electron, or even like Ionic or Capacitor on Android or iOS. So it's really a winning strategy. If we look at the time spent on desktop systems, we see that around 65% is spent inside of a web browser. The number is actually bigger than that because a lot of the native apps like Slack and maybe Visual Studio Code are actually mostly web apps as well. And as you see, more than 60% of the developer community know how to use JavaScript. And even in 2021, last year, PWA adoption grew by 270%. Those are quite amazing numbers. If we dive a bit closer, I think this is very interesting to see people use the web a little bit more on the weekend. But if you look at the browsers, those are top apps on PC. Like Chrome is the #1 app on this is on Windows. Then you have Edge. Then you have Firefox. Then you have Outlook, and Outlook is becoming a progressive web app. Then you have other browsers. Then you have Excel, and like all Microsoft 365, all of those are also becoming progressive web apps. So it's basically all web. But apart from just having like nice UI and all these like nice components, we talked about like you need all these different capabilities so that you can build these applications that people expect. And this is going really great. Like we're having like seamless paste and copy on desktop system today, frictionless access to local file using file system access, and safe access to external hardware such as web Bluetooth and the like. All of this is the Project Fugu effort. That is a project and effort shared between Intel, Google, Microsoft, and even Samsung Internet and others, where we're really trying to bring down the gap between native and the web. So one of the examples here is that, for instance, Visual Studio Code on the web using the file system access API can actually run directly in your browser. So that's pretty amazing. I can borrow my dad's computer and just type in, and I can get ready. Super amazing. Also, like an old application, a very important one, Photoshop. Like if they create a native app, if they want to be available, let's say on Chrome as well, they also support progressive web apps and Android apps. Well, they can be because they can move to the web, and they have done that using WebAssembly. WebAssembly has made it possible to reuse a lot of the existing code, and the features we've been working on, such as like multi-threading, was essential as well. Halide is an important part of Photoshop, and Intel worked together with others on a technology called SIMD. It stands for single instruction, multiple data. That basically means that instead of saying like 1 times 5, you can multiply maybe a vector, like you say like 1 and 2 and 5 and 7. All of these values should be multiplied by 5 and 1 instruction. Adding support of that to the web has on average provided a speed of 3 to 4 times, and in some cases up to 160 times. That's pretty amazing. Another application here I think is very interesting. This is for education. So this is iRobot. You might know iRobot for cleaning your floor at home. They have this education tool. It's very nice. You can draw on paper and the like and program it directly in your web browser. And this works on every platform that supports web Bluetooth. So just connect through Bluetooth, and there you go. Super amazing. A lot of people are a bit scared about like, oh, right, this is kind of scary with all these like native apps and like web apps accessing these like powerful capabilities such as Bluetooth and USB. I actually believe that a lot of like native app kind of offers fake safety because you might install them, but then they have access to everything on your system. They can do a lot of powerful, which you can't on the web. On the web, we're really working on making this as obvious as possible to what's going on and as safe as possible. For instance, you get a dialog and you click on the device you connect to, and that website doesn't know any other like Bluetooth devices around you. So we always try to improve on this. So and we'll constantly be innovating and refining our approaches. So what is the focus at Intel at this point? Well, our main focus in my team is working on capabilities. At Intel, we always say like no silicon left behind. And as the desktop is moving to the web, we need to make sure that's still the case. And then like performance, we really want like near native performance. And of course, we're optimizing, making sure that everything runs smooth on our hardware and uses this to its best abilities. So some of the things we're working on is, of course, WebAssembly, doubling down on SIMD support, multi-threading support, still maintaining WebGL is very important, used a lot out there, but also working on a replacement to WebGL called WebGPU. So here you're really working on the spec and implementation. And in many times, it's like, I think on average, in the demos we've done, is 3.7 times faster than WebGL. I find that's already quite amazing. And of course, like machine learning is super important. So we're bringing machine learning in the form of the Web Neural Network API to the web. And we're seeing amazing numbers. So one of the examples of what we're doing with SIMD is SIMD actually can work on different vector sizes depending on hardware support. So the spec in WebAssembly only support of sizes 128. That's basically 4 values of 32 bits. But we have like hardware that supports, for instance, 260, 56-bit SIMD. And now we can like automatically identify many of these cases and auto convert the code to use this other hardware without you as a developer making any change. And as you see here on the right, like even that it's in one case, it's even like 1.5% faster. So this is also pretty exciting. And we're just getting started with that. Also, the media pipeline, we've been working on the web codec API. So a lot of hardware supports, like, for instance, native AV1 decoders and encoders. So being able to use that in something like streaming, like I'm on StreamYard now, or using in say like Meet or Zoom is very important. And we've been working on that as well. But like performance is also very important. All our new chipsets using a hybrid architecture, also very known for mobile systems. So we have like efficiency cores and performance cores. So by being able to identify some of these threats, like here say signal, network, and worker, this is from WebRTC, we could make sure that these only run on, for instance, efficiency cores. And making that change, we save like more than 100 microwatts of power in Windows. And same thing with playback of video, making sure this works for every platform, like making sure that we're not doing a lot of like inter-process communication, cutting that down. So that's an implementation detail of how Chromium works. We can, like, in this case, we save more than 10%. So this is just like an example of how we try to optimize everything on our hardware, but also it generally benefits any kind of hardware, a lot of these optimizations. Web neural network is extremely exciting. For instance, here we're looking at MobileNet, and this is with TensorFlow Lite. If you look on the left side, and there's the baseline that is XNNPAC delegate using WebAssembly and SIMD. So that's like 1. If you move to using threads, then you get to like a 3-time increase in performance, really good. But if you use our new WebNN, which is work in progress, you get 9.6 times better performance. And a native implementation is 9.8 times faster, so it's almost as fast as native. And this is across the board, really exciting. One of the partners we worked with is Zoom, so like they've been bringing that to Chrome OS as a progressive web app. So here working on web codec, making sure they can use the hardware we have available, but also working on like newer features that you can use without basically just like turning on a flag or setting a Boolean, would allow us to do things in hardware as eye gaze correction, lightning correction, noise suppression, and the like. Very, very exciting things for media. Personally, I'm working on compute pressure, and that's a new spec that allows you to know how the pressure of a system. So you can imagine, like, if you're doing a lot of different things in your computer, it might get a bit warm. It could also be using a lot of the camera. It might be throttling because it can't keep up. So sometimes that's not the best. For instance, if I'm in a meeting and I want to take meeting notes, it's kind of nice to be able to type and not having like, oh, why nothing is happening while I'm typing? And then suddenly you see a lot of letters on the screen. So as an application, being able to maybe adjust the number of video feeds, adjusting resolution, removing unneeded features, like for instance, filters, this is very important. So we're trying to come up with a very nice API that's very high level. So you just get like a state, like if it's barely being used, it will be called nominal. That's the pressure state. If it's normal usage, it's called fair. If you're doing pretty well, but you can still keep on going, but don't do more work, it will be serious. Critical, yeah, maybe now you should try to do a bit less, otherwise the system might be stressed. So very simple API. Here's just one example to show how to use it. I won't go into detail because of time. And with this is basically like the conclusion of what we're doing at Intel. We're really trying to improve what you can do on the web by making sure that no silicon is left behind. Everything is optimized for our hardware, and making sure to always provide the best performance for web apps and getting access to all those nice capabilities that you have on your systems. But what is really important is that this is a journey we're doing together with you, the developers, and we really want to collaborate with you. So this is both in like the standardization organization, the World Wide Web Consortium, but even on Twitter or today on Discord. Like, get in contact with me if there's anything you want to talk about, if any feedback. I'll try to connect you with the right people. And with this, like I said, let's win together. The web is doing great, and enjoy this conference. Very nice talking to you. Bye.